Now, I kindly request Dr. M. Senthilkumar to give his presentation about the activities of Central Groundwater Board and outcome of National Aquifer Mapping. Over to you, sir.
Good morning and welcome back. My presentation will be more focused towards the activities of Central Groundwater Board. What and all data we have, what works we do, what data is collated with us, so you can put into research activity. What and all data is available with us, how you can put into research activity. First part will focus on that. Second part will be on one of our major study, that is the aquifer mapping. We have just put some case study in that. So how we have done aquifer mapping. So in that field also, what are the activities we have done? So where data is being generated, how it is being used by different communities, researchers, by implementers, by administrators, we'll be seeing one by one. So if you see the layout, the first three part is the activities. The second part is the outcome of the National Aquifer Mapping. A background information about the water resource scenario of the India. This is a very common thing, most of you would have seen in many slides. But why I have put this is because to emphasize the need and where we stand as on date. If you see, this is our country's scenario. We have a land of about 2.4%, 4% of water, and 17% of human resource population. But our resources are very, very limited. We have a surplus rainfall. See our precipitation, almost in the range of 4,000 BCM. Is the precipitation we receive, out of which 2000 BCM is the utilizable resources. That is the resource that is being generated, out of which we use about 1120 BCM of water. 690 comes from the surface water and 436 from the groundwater. This is fine as of now, but with the growing population, urbanization, industrialization, this scenario is changing in the coming years. By 2050, we require around 1180 BCM of water for all the needs. It should be industry, agriculture, then for domestic needs. So we should be in such a situation that we do not depend upon other sources for this naturally occurring water resource itself. So if you see this is the different sectors, how they are utilizing now and how it is being projected by 2050, what will be their requirement. So this assessment, how much surface water is there, how much groundwater is there, is being done periodically. If you see the groundwater resources, this is the interesting fact. So this is the real stats of groundwater. You see this figure on the right side, how the groundwater curve of India has gone up. From the green revolution to the industrial revolution, from 1970s, this has skyrocketed. If you see our old history, in 1970s, India was water surplus but food scarce. Now we are food surplus, but water is now becoming a scarce and a commodity. This relentless, today in our inauguration also, all our speakers were telling how discriminately groundwater is being used. Because of this indiscriminate groundwater withdrawal, what has happened is over-exploitation of groundwater. Because of this, we see several environmental impacts. Drying out of rivers. Many small farmers are committing suicides because they don't have water in their well. They are not able to do their own agricultural activity. We have groundwater contamination issues. Since we are going deep by deep, we have now increased contamination issues of arsenic, fluoride, and recently now we have found uranium in groundwater also. Our case of Tamil Nadu, in few pockets we have identified uranium, but the worst case is in Punjab. There are 2 districts in Punjab which has been now categorized as the cancer districts of this state. This is only because of uranium in groundwater. People do not know they have uranium in that groundwater. They start drinking it, and with time the health complication starts. So This was the background of water as well as the groundwater. And what we do, we are an apex body under the Ministry of Jal Shakti, looking after the sustainable development and management of groundwater resources of the country. This is our vision, and our mandate is to disseminate and develop technologies, manage groundwater resources, all its activities, either exploration, we identify strategic resources, identify it, explore it, assess what is the quantum available, how much it can sustain. All these activities we do in a nutshell for the entire country. So we have our presence all pan over India. We have about 18 regional offices almost in all state capitals. We have about 16 third level laboratories, out of which 8 are NABL accredited. All these sophisticated instruments you name in groundwater analysis, we have it here. We are now analyzing the arsenic, uranium, everything in our labs itself. We have about a fleet of about 80 rigs to do our exploration activities, either in a hard rock formation or in an alluvial formation. We have a dedicated training institute located at Raipur, which offers a wide range of trainings, about 50 to 60 trainings a year, and all the trainings are free of cost. It is completely, we have a boarding, lodging, all the facilities are available, and now we have started also an international training for groundwater modeling and remote sensing. These are our major activities, what we do. Now the major activity is NACUM, National Aquifer Mapping and Management Program. We will be seeing it in the subsequent slides. We do water level and water quality monitoring through a set of network monitoring stations, groundwater exploration, artificial recharge in areas where there is falling water levels, declining water levels. We also provide solutions for defense establishments, source sustainability under Jal Jeevan Mission, groundwater assessment. Every year we assess the groundwater resources, quantify how much is getting replenished every year, how much is the withdrawal. We have a dedicated training and a capacity building institute. Apart from that, there is a groundwater regulation also, Central Groundwater Authority, which is doing the regulation for the entire country. Tamil Nadu at a glance, if you see, about 73%, this is a very common slide. Why I put this is because just to understand what we do and how it is done. 73% is a hard rock formation and 27% is an alluvial formation. 38 districts, population, this is a very common feature, stat. We have drilled about more than 2,000 wells. So these information, these are subsurface informations which are recorded and which is available completely. Groundwater exploration is an important research activity wherein we explore what is the resources available below the surface. In a surface water, you can easily see the flow of the river, its velocity, but in a groundwater, it's a difficult situation. We do all studies to understand what's the flow rate, underground water flow rate, at what speed it is flowing, how much is the quantum of water available in each stratus. Different aquifer units, different stratas, what is its characteristics, what is its quality. So all these wells, after complete analysis, either being the aquifer parameter estimation, after the water quality analysis, this is completely handed over to the state departments free of cost. Nothing we maintain, everything we give it after that also. Then we have a dedicated monitoring network stations, about 1400 stations from where we get regular water level and water quality data throughout the year. Now about 1000 stations we have completely automated it. Every 6 hourly data is being received in our servers. One example, we have just placed it on the left hand side. There are about climate response stations also, which we have installed in the coastal areas, from where the groundwater level as well as the water quality data is also recorded, and this data is also transferred immediately to the servers through telemetry system. This data is completely available on the portal also, India Waris portal. The entire data is available, 50 years data from 1972 to current date. The entire data is completely free of cost and it is easily downloadable. Apart from that, we also prepare several bulletins after each monitoring, how the groundwater level is behaving, just to understand how the situation is, which are the areas which are worst affected, which are having shallow areas, where we can do exploration, where we need to do recharge activity. Similarly, water quality, different parameters. Every year we get certain number of samples. These samples are analyzed and these maps are updated. This data is also completely available in the India Waris portal. This is the area which we were talking about, high uranium concentration. We have a topic on water quality also, the areas where we are recording high concentration of uranium. The other important activity is the estimation of groundwater resources. This is the assessment of groundwater resources. Every year we do this assignment since 2022. But earlier we used to do it once in 3 years. Now it is an yearly affair. We have developed a robust methodology called as Groundwater Estimation Committee, GEC they call it. And based on this methodology, we do the assessment of groundwater resources. Every year, how many assessment units are overexploited, how many units are in the safe category, how many are in the saline category. This categorization paves ways for regulation. So industrial development will not take place in these overexploited areas. In safe areas, we promote more industrial activities. You can see these are the red patches are the patches where the groundwater is under stressed condition. With years, this is 2011, the assessment, 13, 17, 20 and 22. How the red patches have declined. This is because of several interventions. Several recharge measures have taken place. Several other activities have taken place. Because of this, overexploited units are coming down. So in areas where we find more overexploitation and the groundwater is in a high stress condition, there we have taken up some pilot recharge studies also. Throughout the plan period, from the 7th plan, almost from 2000 we are doing several recharge studies. Almost 700 lakhs we have spent to demonstrate what is the recharge structure that is feasible for that area. Best examples are in Gangaveli, the entire Coimbatore city, where it's an urban population, how the water can be captured, how the rainwater can be captured and recharged. That has completely been done. One good example is our campus which is adjacent to us, CLRA campus. People who were passing through this road 15 years back would know, immediately after the rainfall, this Gandhi Mandapam's signal would get flooded off because of the rainwater. One structure there has completely changed the scenario. The excess flood water is also harnessed and it is getting recharged. That has resulted in the CLRA expenditure has completely come down, which they used to buy tankers every day. That has come down because of this recharge activity. So it has both the benefits. You are harvesting the flood also. At the same time, you are also recharging the groundwater and increasing the water level. We have also prepared a master plan for artificial recharge. This is as on 2020 and now this year we are again updating it. We have also recommended what are the structures, where it is suitable, what are the design. Apart from that, we have also taken up a sophisticated heliborne geophysical survey. A sample study we carried out in Kadalur, wherein a low-flying helicopter with an electrical loop. We passed current and found the subsurface strata up to 300 meters. So what this does is, it gives complete picture of resistivity of different layers. From the resistivity, we are able to identify what is the formation, what is its quality, what is its characteristics. This data set is also completely available. So, moving on to our next part, the national aquifer mapping. In the previous slides, you had seen how the groundwater is being indiscriminately utilized. So in view of that, government in 2012 launched a major program to made a paradigm shift from groundwater development to groundwater management. The main objective was to know your aquifer, manage your aquifer. So if you know what is the dimension of any object, then only you will be able to understand how I can solve the problem. That was the motive behind that. So with that, what we did was, we tried to delineate and categorize how many aquifers are there in that and provide management solutions for the aquifer system. So what goes into an aquifer mapping study, NACUM study? It is a completely an integrated study. All these studies we have just integrated into a single platform: hydrogeological, hydrological, geophysical, exploratory drilling, hydrochemical analysis, then groundwater level and assessment, all put together with the aid of advanced geophysical technique also. All this we put together, and what was in a 2D, something like this, changed into something like this. So the entire country is about 32 lakh square kilometer, out of which 25 lakh is completely mappable. And we covered this in less than 10 years. No other developed countries have also done it. Only Australia has done it in some part of its area. United States takes 3 years to cover 1 lakh square kilometer. Small countries have attempted. Netherlands has done it. Then United Kingdom in some part has covered it, where the aquifers are there. So this we completed in less than 10 years for the entire country, 25 lakh square kilometer. When we come to Tamil Nadu, the area is 1.3 lakh square kilometer, and we covered it in less than 6 years. And we have the entire 3D aquifer system, 3D maps, 2D aquifer disposition, everything for the entire state into different aquifer layers. So what you expect from an output of that? All 3D disposition, then the depth and occurrence of aquifers at different locations. What are their yields? Chemical quality, what is their resource? Then we have management plans, something like this, where you can do artificial recharge, where you need to focus on demand side management. All these data are completely available. This is one example of an high yielding well where the groundwater is of a good concentration. So once this data we have completed it, what we do with that? We share it with the state departments at different platforms. We have state level coordination committees where we share it with the administrators, where the principal secretaries, the additional chief secretaries are the head of the committees, and the line departments are the members of that. We share it with the district collectors and district magistrates because they take care of their districts. At grassroots level, we conduct large number of PIP programs, participatory programs, wherein we concentrate towards students, farmers, all the communities. Then entire data is available on the portal also. So with this background, I'll just put a small case study of Chennai aquifer system, how we have approached the study and how we have completed the study. This is Chennai aquifer system, an area of about 6,200 square kilometers, manifested with several problems. You can see a coast in the eastern side, so there is a threat of seawater intrusion. Heavy groundwater withdrawal for Chennai city from the adjoining areas, the peri-urban areas. This has resulted in seawater intrusion in North Chennai and South Chennai. The entire land has become saline. Groundwater is saline. 16 kilometers inland, you can see the best example is Minjur. 16 kilometers saline water has intruded into the freshwater aquifers. So the real estate, there is no activity there. There will not be any agricultural activity because of seawater intrusion. We have industrial clusters in this area, biggest landfills. Apart from that, the formation itself is of poor quality. It has low yielding capacity, this green patch. This is one patch. This is called as conglomerates. It's a mixture of several formations cemented together, cemented through a silica material. So this has very low potential. The people living there will get very low yields. With this, we carried out an aquifer mapping study in that area and identified which are the aquifers that are available in that area, what is its quality, what is its characteristics. So an example, something like this. This is the alluvial aquifer, this is the conglomerate aquifer. What is its characteristics, what is its quality, all the information. Then we quantified how much recharge is taking place in this area in a single year, in a monsoon, non-monsoon period. Then what is the withdrawal? How much groundwater is being withdrawn? How much surface water is utilized? Something like a complete balance, just to make a study. This is the quantum of water. Almost 900 MCM of water is withdrawn every year. Then we proposed several supply side and demand side management strategies. Supply side, like recharge structures in the tune of about 56 crores. Several structures like check dam, Nala bunds. So we will be able to recharge about 54 MCM of water. And on the other side, what we tried is agriculture is consuming more water. So if we take less water, that also will save our water. So we proposed a demand side change, like change in irrigation pattern. You cannot ask the farmer to change the crop. He will not be willing to do it. So you can ask him to change the irrigation pattern. Instead of doing a flooding method for a rice, he can go for a ridge and a furrow. That will consume only 50% of what water is required. Then sugarcane and banana, now they are moving it towards drip. That itself reduces the water consumption. By this demand side strategy, we will be doing about we will be having an expenditure of about 125 crores and we will be able to save about 65 MCM of water. So both the activities, if done together, the stage of development from 103 will be brought down to 68%. From an overexploited category, this is moving towards a safe category. Same with all the data, we simulated the model also. What will happen to this area in future? Because frequent failure in monsoon we are facing in this area. Frequent droughts are there, frequent floods are there. So what happens to this area in the future? 10% increase in draft, 25% increase in draft. Already seawater intrusion is available, has already intruded into this area. 25% increase in draft, the system itself becomes unstable. So up to 15 to 20% it can accommodate. Beyond that, the system is becoming unstable. Then the recharge measures which we are proposing, what will happen if all the recharge activity takes place? So these are some of the areas where we are seeing some potential improvement in the groundwater levels. Then the further to advancement of that study, what we have done is, we are planning to link the two rivers. People common in this area would know there are two rivers, Arniyar and Kortliyar. These are nothing but the flood waters. They carry only the flood waters and the remaining time it is completely dry. So what we have planned is, we have planned to connect both the rivers through an unlined canal. And during the lean season, where there will not be any flood, the treated water from the desalination plant will be poured into this to push the saline water towards the seaward side. So this study we have just started and this will in the pipeline. And what next? This is the future course of NACUM 2.0, where we are moving more towards improved data density, intelligible outputs and implementable plans. Some of the implementable plans we have displayed here also through district recharge plans, where we have kept geo-coded locations where you need to do what structure at which place. So now we will be more concentrating on these water stressed areas, coastal areas, urban agglomeration, spring sheds, industrial areas, floodplain aquifers, command areas, deep-seated aquifers, areas with transboundaries, and finally poor groundwater quality areas also. These are our plans for the coming years. So what aquifer mapping we have done is in 1:50,000 scale, and this will be at the village scale. Thank you.
Sir, good afternoon, sir.
Sir.
Sir, Krishnkumar from Mahalingam College, sir. Is there any impact of chemical fertilizers in the agriculture field used in the groundwater, sir? In your studies, any?
Definitely.
Yes, sir.
Definitely there are, we have a lecture today from Dr. Ravichandran.
Okay, sir.
He will be talking more about the impact of the fertilizer also.
Okay.
The case study which I was telling you, this cancer districts in Punjab. Actually, these are being instigated by fertilizers.
Okay.
Actually, uranium is present in the soil, aquifer matrix itself.
Okay.
But one fertilizer is causing the release of uranium from the soil to the water.
Okay.
So there are several studies.
Okay.
We have several examples also.
Thank you, sir.
This is Bhakya Lakshmi from Savita Engineering College, sir. So I have a question regarding this WRIS website, if I may ask. Yes. So I use CGWB data a lot for my research work. Basically an agri-engineer. So when I try to download the well data, for example, for an entire basin, I have to go through each and every stations individually and get the data, and also download this latitude, longitude.
Okay.
So is there a way that everything is consolidated in a file, like a shape file and a table kind of thing?
Okay. Shape file, if you give a request, automatically they will send.
Okay.
And all the well IDs, if you notice the well ID, it is latitude and longitude.
Yes, yes.
It starts with W, it's a latitude separated by a 0, then longitude.
Okay.
So you need not ask them separately. You can use the well ID itself for location.
That's what I'm doing. I'm doing it manually. Like for example, if I do download for an entire basin, it becomes a very tedious work. So that just wanted to know.
If you require a bulk download,
Yes,
as of now they have not kept bulk download.
Yes, yeah.
But for a basin you can do a download, I think so.
Even then I have to go through individual stations and then get downloaded.
You have the options to select individual stations.
Yes, sir.
In a basin you can select all the stations or leave out some stations also. That option also is available.
Okay, if I select all the station, everything, all data will be
all the
downloaded
data
together.
will come.
Okay.
All the data will be done.
Okay, thank you, sir. And another question was, when you do this geophysical survey or anything, how far do you go actually to define the stratum characteristics and all?
See, in our national aquifer mapping, our envisaged target is 200 meters for hard rock and 300 meters for the sedimentary soft rock formation.
Okay.
So till that depth we do the spreading of it.
Okay, thank you, sir.
Sir, good morning, sir. This is Dr. Venkatesh from Savita Engineering College. Sir, you have mentioned that the quality of our state right now, the uranium and the nitrate, all those things. What are the precautions as the government we have going to take care, sir? What are the precautions we have to take for that, sir?
Precautions.
Yes.
Okay. So actually we give several advisories. These are the areas where the groundwater is free from contamination, and these are the areas which are being contaminated. Where the Jal Jeevan mission, they take assurance of the quality.
Okay, sir.
They take the treatment and
Okay,
they
sir.
supply the water.
Okay, sir. Thank you, sir. Such a wonderful presentation.
Thank you.
Thank you, sir.
Good afternoon, sir. I am Hari Ganesh from Coimbatore, Sri Ramakrishna Engineering College. I have a small doubt about the recharge of water. So basically this recharge of water will take about 100 to 200 meters down, but we are taking water from 800 to, even it has went to a depth of 800 to 1000 feet, right? So this recharging capacity is nearly around 100 to 200 feet, I think so. Is there any chance that it goes beyond that 200 meter ground, whether the recharging is possible? Because we are taking water from solid rocks, which is under 1000 meters or 1000 feet. So what is the source for that water that is inside the rock at the 1000 feet? Or is there any possibility to recharge up to that depth? Or what may be the cause of extraction of water at that depth, because at depth we are taking the water. Then when we are extracting the water, there will be some vacancy or there will be some vacant spot. What will be the adverse effect of that vacant spot? So if we limelight on that aspect, what will happen to the geological or hydrogeological surface of those areas where we are taking water beyond the depth of 1000 feet? And also regarding this tanks and bond structures. So we are creating tanks and bond structures, and in urban cities we have many lakes and ponds where we store water. But even though we are storing water, the recharging capacity of the land below the lake or pond is very less due to the deposition of that sewage. Because of in urban we will have that sewage water inclusion, because of that all settlements there is the percolation of water is very minimal. So what about that cases, sir? Because we are creating ponds and lakes, bunds everywhere. So what is there any plans to maintain that bunds, or what about even though we desilt, when about the maintenance we go for desilting, up to there is some adverse effects of desilting also. So what about the recharging capacity of that? My question is based upon the recharging capacity of the water, up to which depth the water can be recharged, and what about the vacant space that is created at the 1000 meter depth? That's all.
Okay. See, what water we extract from the depth is the water which is getting recharged from a distant location. Somewhere else it is exposed. So in the next lecture, in the source sustainability, this is the most covered topic. Okay. So from where it is getting recharged, how deep you are extracting also, its source of recharge would be an adjoining area where it is exposed in the surface itself. And regarding the vacuum created, if it's in a sedimentary area, we will have subsidence issues. Okay, simple example would be, you would see lot of cracks getting developed in the buildings if the land is subsiding down. In a hard rock formation, usually this does not occur because water occurs in fractures. So there will not be much environmental degradation of extracting water from a deeper extent. So in my next speaker would be covering more about the lakes, ponds, how the desilting is taking place, what is its impact, everything.
Sir, good
Yes.
afternoon, sir.
Good afternoon.
I am from Sri Muthukurman Institute of Technology, Chennai. My question is, any sponge city is possible in Tamil Nadu? In urban places, during rainy season, a lot of waters due to blockages, high density, so a lot of waters lacking in the surface. In drainage system is low in our areas. So any possibilities in sponge city, any techniques in sponge city introduced in Tamil Nadu?
Sponge city. In the next lecture, he will be covering more about that. Thank you.